Since the correct operation of the landing gear is of the utmost importance, a number of safety features are included in the retraction and extension systems to ensure its correct operation under all conditions. Safety features are also built in to stop the gear being retracted when it's not safe to do so, and to warn the crew if they are attempting to land with the gear not extended. In this lesson, we will discuss these safety features. To avoid damage to the airframe structure, the nose wheel must always be aligned in the fore and aft direction prior to retraction. A number of methods are used to ensure that this happens automatically. One method already discussed is hydraulic nose wheel centering on aircraft with powered steering. Other systems use a self-centering cam, which will move the nose wheel into the correct position as the oleo-pneumatic strut extends on takeoff. To prevent inadvertent retraction of the landing gear when it's not safe to do so, a safety device is incorporated which prevents the landing gear selector lever being selected up. This safety device consists of a mechanical lock which retains the selector in the down position and is released by the operation of an electrically operated solenoid. On smaller aircraft, electrical power to the solenoid is controlled by switches mounted on the main gear shock absorber struts. When the struts are compressed, the switches are open. But as the struts extend after takeoff, the switch contacts close and the electrical supply to the solenoid is completed, thus releasing the selector lever lock and allowing the landing gear to be selected up. On larger aircraft, a number of additional criteria have to be met before it is safe to raise the gear. For instance, the main gear trucks may have to be tilted to the correct angle, and for the aircraft with body gear steering, the gear will have to be aligned fore and aft. Only then will the lever lock be released. A means of overriding the lock, such as a separate gated switch to complete the circuit, or a mechanical means of releasing the lock, is provided for use in the event of solenoid failure and for maintenance purposes. Flight crews should exercise great care in using this bypass facility. Normally, it should only be used when called for in a checklist, as raising the gear hydraulically, when parts of it are incorrectly positioned, can cause catastrophic damage to both the gear and the airframe. Landing gear ground locks, or locking pins, are further safety features which are intended to prevent inadvertent retraction of the gear when the aircraft is on the ground. They will usually consist of pins or metal sleeves which interfere with the operation of the gear in such a way that it is impossible for the gear to move when they are in position. They are fitted with warning flags which help prevent the crew from inadvertently getting airborne with them still in position on the gear. If they are still fitted when the crew do their external inspection, a further external check should be carried out after they've been removed, as getting airborne with them fitted will often require the dumping of fuel before landing again to have them removed. On some aircraft, after removal, they are stowed on board in a position visible to the crew. To guard against landing with the landing gear not locked down, an oral warning is incorporated in the system. An oral warning isolation switch is often provided to allow certain flight exercises to be carried out without unnecessary warnings. Different aircraft types use different criteria for the operation of the oral warning and isolation switch. These normally involve a combination of flap and throttle positions. In a typical system, If the flaps are at an intermediate position, with the gear not locked down, and one or more of the throttles are retarded, the warning will sound. The isolation switch can be used to silence the warning. If, however, landing flap is selected with the gear not locked down, then again the warning will sound. But operation of the isolation switch will not silence it. If fitted, the Enhanced Ground Proximity Warning System, EGPWS, will give a too low gear warning, passing a specified radio altitude with the gear not locked down. EGPWS is covered fully in the series of lessons on aircraft instruments. A means of lowering the landing gear and locking it in the down position is provided to cater for the possibility of failure in the normal system. In most modern aircraft, the uplocks may be released electrically, as in the case of the Boeing 747, where the switches control electric motors which operate the uplocks, or mechanically, as in the case of the Boeing 737, where the handles in the cockpit are connected by cables to the uplock release mechanisms. In both of these cases, once the uplocks have been released, the landing gear lowers or free falls under its own weight, and the downlocks are engaged mechanically by springs. In the typical system depicted here, pulling the handle to the first detent releases the door uplock, allowing the door to fall open. Pulling the handle to the second detent releases the gear uplock, which allows the gear to drop to the down position. A heavy spring in the downlock actuator forces the over-center mechanism into the locked down position. If the gear has been lowered by this free-fall method, there will be no power available to close the hydraulically operated doors after extension, so they will remain open, and the door open light will remain illuminated. On some aircraft, the landing gear can be extended by an emergency pressure system, which may use alternative pipelines to the jacks. Pressure for the emergency system may be supplied by a hydraulic accumulator, a hand pump, an electrically powered pump, or even a pneumatic storage cylinder. That is the end of the lesson. You should now know how the landing gear can be lowered in the event of a hydraulic system failure. You should be familiar with the methods used for preventing the landing gear retraction on the ground and for preventing a landing being made with the gear up. Remember, however, that these systems are not foolproof. The pilot is ultimately responsible for ensuring that the aircraft is in the correct configuration for the phase of flight.